So good evening everyone, I am Chair May Sanchez and I am one of the Group 5 members, and for today's topic we will discuss about probabilities and normal distribution as well as linear regression and correlation. So these are the Group 5 members: I, Chair May Sanchez, Shelo Katubag, Shine May Bales, and John Bert Dabuco. So for this topic, we have probabilities and normal distribution, and we will give this part to Shelo Katubag.
So the normal distribution or Gaussian distribution is a continuous probability distribution that describes the cluster around the mean. The normal distribution can be used to describe at least approximately any variable that tends to cluster around the mean, often called the bell curve. The associated probability density function is a bell shape, said to be normally distributed, and is called a normal deviate. A continuous probability distribution that is symmetrical on both sides of the mean. Normal distribution: a symmetric bell-shaped curve, a graphical representation of the normal distribution. It is determined by the mean and standard deviation. The wider the curve and the larger standard deviation of the more variation exists. Properties of a normal distribution. A distribution is a bell shape. The mean, median, and mode are equal and are located at the center of the distribution. The normal distribution is an unimodal. The normal distribution curve is symmetric about the mean. The normal distribution is continuous. The normal curve is asymptotic. The total area under a part of a normal distribution curve is 100% or 1. The area under a part of a normal curve that lies within a standard deviation of the mean is 68%. But within two standard deviation, it's almost about 95%. And with three standard deviation, it would reach 99.7% or almost 100%. Normal distribution. Since the normal curve is symmetrical, 50% of data lie on each side of the curve.
So good evening everyone, again I am Chair May Sanchez, and for my part of a report, I am going to explain or to discuss what normal distribution and standard normal distribution is. So ang normal distribution, as Shelo said, it is often called the bell curve because of its shape nga nagform og bell. So mao ni siya ang example of a normal distribution curve, and it already has the given data, which is kaning mga numbers sulod sa curve. So sa i-explain ni Shelo nga ang normal distribution curve has 50% of the data lie on each side of the curve. So it means if 50% diri nga side, 50% sa diri nga sa pikas nga side. And we have our mean, which is given na siya kining ubos na sa tunga, which is kining 68.2%, 95.4%, og 99.7%. And always keep in mind nga ang mean is always located at the center of a normal distribution curve. Pirmi ang mean sa tunga. So in order to construct this data, kining area sa normal distribution kanina sa sulod. So if we take this number 68.2% and divided by 2, makakuha tag 34.1% sa area between the mean, which is kini, to the first standard deviation, kini nga part diri padong diri, makakuha tag 34.1%. mao ni siya diri sa sulod. Ato ra siyang i-divide by 2 para makuha ni siya diri asa mean to the first standard deviation. Kung 34.1% diri nga part, 34.1% po diri sa pikas nga part diri nga area. Kay ang ato ang standard normal distribution is symmetric man. So kung unsay naa diri, mausay naa diri sa pikas nga area. So next is kani nga area, kaning yellow. So in order to construct this data, or in order to para makuha ni siya nga data, if we take the number of 95.4% subtracted to 68.2%, makakuha tag 27.2%. Divided by 2, maong nakakuha tag 13.6. So kaning 95.4% atong isubtract sa 68.2% and ang iyahang mugawas nga answer is atong i-divide by 2 maong makakuha tag 13.6%, which is mao ni siya diri nga answer from the first standard deviation to the second standard deviation. Mo nakakuha tag 13.6% sa area diri adapit. Maura sa diri sa pikas nga area diri 13.6 pud ihang answer kay as I said symmetric ato ang normal distribution curve. So kung unsay naa diri maura sa gihapon diri nga area. Next is kaning red nga part, which is kaning 2.1%. So maura gihapon nga process if we take the number of 99.7% subtracted to 95.4%, makakuha tag 4.3%, divided by 2, maong makakuha ta og 2.1% diri nga part sa red. So last is kining pinakaubos sa curve, which is kining 0.1%. So in order to get this 0.1%, we need to add all the total number of a normal distribution curve. So kung 50% ni diri tanan, then 50% sa diri sa pikas tanan, natay 100%. If we take 100% subtracted sa 99.7%, kani makakuha tag 0.3%, divided by 2, maong makakuha tag 0.15%, or simply as 0.1% nga mao ni siya diri nga area. Maong nakakuha tag 0.1% diri nga area kani sa pinakaubos sa curve. So next is the standard normal distribution curve. So ang standard normal distribution curve is a normal distribution with a mean of 0 and standard deviation of 1. The standard normal distribution is centered at 0 and the degree to which a given measurement deviates from the mean is given by the standard deviation. So naatay standard normal table or the Z table, mao ni siya ang table, and we have an example, which is kini. Find the area under the standard normal distribution curve between z is equal to 0 and z is equal to 1.77. And the first thing that we have to do is maghimo tag normal distribution curve. Mao ni siya para mas ma-visualize nato. So the mean, which is 0 kani permi siya nasa tunga sa normal distribution curve, and this is the first standard deviation, which is ang ato ang z first standard deviation, which is 1.77, and so mao ni siya nga area but from mean to the first standard deviation mao ni siya nga area ang atong identify. Now by looking to this table, which is kining standard normal table or the z table, makuha ni nato siya nga area, which is atong mean nga 0 padung sa first standard deviation, which is 1.77. Makuha ni nato nga area by simply looking at 1.7 and 0.07 diri sa atong table. And ang intersection ani nilang duha is mao ang area sa ato ang standard normal distribution curve. So ang area sa atong standard normal distribution curve is 0.4616 or 46.16%. Ang area under the standard normal distribution curve between z is equal to 0 and z is equal to 1.77. So mao siyang area sa ato ang kani standard normal distribution curve.
Hello guys, good evening. I'm John Berg. So let's talk about probabilities and normal distribution. According to the German mathematician Carl Friedrich Gauss, who first described it, the normal distribution is often called the bell curve because the graph of its probability density looks like a bell. It is also known as called Gaussian distribution. The normal distribution was developed mathematically in 1733 by Abraham de Moivre. 1667 to 1754 as an approximation to the binomial distribution. Take note guys that normal distributions are symmetrical, but not all symmetrical distributions are normal. In reality, most pricing distributions are not perfectly normal. Carl Person is an English mathematician and biostatistician. He has been credited with establishing the discipline of mathematical statistics. Abraham de Moivre's paper was not discovered until 1924 by Carl Person, 1857 to 1936. Simon Laplace, a French mathematician, astronomer, and physicist who was best known for his investigations into the stability of the solar system. Laplace used the normal curve in 1783 to describe the distribution of errors. The correlation and linear regression. Correlation is a statistical method used to determine whether a relationship between variables exists. A variable here characteristics of the population being observed or measured. Regression analysis is a statistical method used to describe the nature of the relationship between variables that is either positive or negative and linear or nonlinear. There are two types: relationship between variables, simple and multiple. In a simple relationship, there are two variables, which are the independent variable and a dependent variable. Scatter diagram is a useful tool for checking the assumptions in a regression analysis. It can be viewed during an initial screening run of the analysis or after the analysis. So, person product moment correlation is the most widely used in statistics to measure the degree of the relationship between the linear related variables. So, correlation efficiency is defined as the covariance divided by the standard deviations of the variables. So, this is the formula to calculate the correlation coefficient. R equals n sigma x y minus sigma x quantity sigma y divided by the square root of n sigma x squared minus sigma x quantity squared, then n sigma y squared minus sigma y quantity squared. Person correlation coefficient is to measure the strength and relationship between two variables and quantifies on how closely one variable is related to another variable that is founded by Carl Person. For example, the owner of a fruit shake stores would like to study the correlation between atmospheric temperature during the summer season. A random sample of 12 days is selected with the results given as follows. So from day 1 to day 12, temperature is referred to the X, the total cells which referred to the Y. From day 1, we have the temperature of 79, and then the total cells is 147. The day 2, we have the 76 and the total cells is 143. As you notice that the temperature varies to the total cells. So look at the graph. So the temperature 75 from 75 to 90 is increasing, and then the 90 to 97 it's like fluctuate. From day 1, we have the 79. The X which represents the temperature, 79, 76, 78, and so on. We have the Y. We have the Y which represents the total surge, 147, 143, 147, 168, 206, 154, 192, 211, 209, 187, 200, 150. So to get the X, Y, you have to multiply the 79 to 147, which is the 11,613. So as you can see na i-multiply ra ang X o Y to get the X at this point. So to get the X squared from day 1, we have 79 times 79 to get the X squared, which is the 6,241. And the day 2, we have 76. So we have to multiply by itself to get this data. So here, so 76 times 76, we have the 5,776. Day 3, 78 times 78, we have 6,084. From day 4, we have 7,056. Day 5, 8,100. Day 6, 6,889. Day 7, 8,649. Day 8, 8,836. On day 9, we have 9,409. Day 10, 7,225. On day 11, we have 7,744. Day 12, we have 6,724. Y squared. So to get the Y squared is we have to multiply the 147 by itself. This is the total sales, which represent the Y. 147 times 147, we have 21,609. Just multiply by itself to get this data. So now we have to substitute the values to compute the Pearson sample correlation coefficient. So it symbolizes R. R equals n sigma xy minus sigma x quantity sigma y. So square root of n sigma x squared minus sigma x quantity squared, and then n sigma xy squared minus sigma y quantity squared. So we have the value of sigma x, we have equals to 1029. The y is sigma y equals 2155. So where did I get this data? So simple. So go back. So money siya ang the total. So the sigma x, so we have 1029. Sigma y, we have the total from day 1 to day 12 is 2155. And then the sigma xy equals 183,222. The sigma x squared, the total from day 1 to day 12 is 88,733. the sigma y squared is 380,887. So dira ko gabase og data to get this value. So the n is 12 days. Na substitute, we have the r equals 12 times 183,252 minus the 1,029 times 2,155 and divided by square root of 12 times 88,733 minus 1,029 squared. 12 times 380,887 minus 2,155 squared. So simplify. We have the r equals 22,329 divided by the square root of 5,955 times 97,419. So we have now the value to calculate that. So try to calculate your own para makuha ang exact, para magka-match. So we have the r equals 0.2705 or i-round off ra. We have the 0.23. So the coefficient of correlation of R equals 0.23 between the atmospheric temperature and total sales indicates a very high positive correlation with a very dependable relationship, that is an increase in atmospheric temperature is highly associated with the increase in total sales of food shake. So money ang yang kuan the correlation. So that's all, and thank you.